Hello everybody. Alright, section 14.3. We are now going to start working with integrals of trig functions. Alright, we've been deriving them, we've been doing things with those derivatives. Now we're going to go ahead and find integrals, and in particular, what I'm wanting to be able to do in this video is to be able to find the indefinite integral of functions that include either a sine x or a cosine x as part of the equation. Alright, so you're about to learn rules for finding the integral of sine x and the integral of cosine x. Alright, well, I want to do something that you ought to be able to do for me really quickly. If you know what the derivative with respect to x of sine of x is, alright, that's equal to cosine x, then you ought to be able to tell me what the antiderivative of cosine of x would be equal to, right? Because we would just be going in reverse. If the derivative of sine x is equal to cosine x, then this would have to be true. The integral, or the antiderivative of cosine x with respect to x would have to be equal to the sine of x, wouldn't it? Plus the constant of integration. Alright, now similarly, you know the derivative of cosine of x is equal to negative sine x, correct? And so if we just apply the same kind of logic, we could conclude then that the integral of the sine of x with respect to x would be equal to the opposite, or the negative, cosine of x plus c. You need to make sure that you write down those two rules. That's the integral for cosine and the integral for sine. You don't have to know the integral for tangent. That's something we'll do in an exercise, but it's not something that you have to do or have memorized necessarily. Alright, so those are the two new rules that you know for integration now. Let's just go through several examples in which we'll use all ranges of skill levels that we already acquired back in chapter 9 whenever we were doing integration before. Alright, and I want to start off with just simply a basic integral with trig functions, and you see that we're going to try to find that particular integral right there, the integral of sine x minus 2 cosine x dx. And what I want to emphasize with this is that we use all the same rules for integration with trig functions that we did whenever we were just using polynomial functions or the sort. Alright? And by that I mean we do little things like this. Whenever you have an integral that involves more than one term, as we do right here, you can split that integral up into a couple different terms. And you can always bring constants to the front of an integral. So I could rewrite this integral as the integral of sine x minus 2 times the integral of cosine x with respect to x. That should be an x right there. Alright, and then it's just a matter of integrating each term separately. We just got done saying that the integral of sine of x is equal to negative cosine x. And then we'll get minus 2 times the integral of cosine x. And we said that the integral of cosine x is equal to sine x. And then we'll have our plus the constant of integration. And I'll just clean this up a little bit. It's actually not going to look a whole lot different in this case when we clean it up, but it looks a little nicer without the parentheses anyway. Alright, so that's a basic trig function, so to speak, in regards to integrals. Now let's go ahead and add in some of the other more complicated things that we learned back in chapter 9. For instance, what happens whenever you have a linear composition involved? Now I'm going to need to write down a rule for you. Alright? When I'm talking about a linear composition, we have a cosine of a linear function. It's not just cosine of x. It's a cosine of 3x minus 1. Alright, and I hope that you remember what we did when we were integrating functions that were compositions with linear functions before, because that's what we're going to do now as well. Here's the rule. The integral of the cosine of a linear function with ax plus b with respect to x is going to be equal to 1 over a times the sine of ax plus b plus the constant of integration. Alright, so if you have a composition of a trig function with a linear function, you're still going to do the integral of the trig function the same way we just said in the rules a moment ago. The integral of cosine is still sine, and you're still going to have the sine of whatever that inner function was before. It's just that you're going to multiply that integral times the reciprocal of the linear coefficient, times the reciprocal of a. And the same thing would happen if this was a sine right here. We would just get this. The integral of the sine of ax plus b with respect to x would be the reciprocal of 1 over a still, times the integral of a sine, which is a negative cosine, right? I'm going to bring the negative sign to the front, make that negative 1 over a. We'll get negative 1 over a times the cosine of ax plus b plus c. All right, so those are two rules that you ought to know and that you'll use in your exercises. Let's go back and find the integral that I gave you for this example, the cosine of 3x minus 1, so we can illustrate how this works. And it is super easy to do this. All right, for this particular one anyway. So for the linear part, we're going to go ahead and take the reciprocal of the linear coefficient. The reciprocal, of course, of 3 is 1/3. And then we'll multiply by the integral of cosine of that function. So that's going to give us sine of 3x minus 1, and then plus our constant of integration. All right, not a lot to that at all. Now the next couple, there's a little bit to them. Because, remember, we've got to be able to use the substitution method in order to integrate some functions, and so we're going to do the same when trig functions are involved still. Now this one looks pretty darn complicated, right? Well, here's the idea with the substitution method, of course. You see that we got the cosine of e to the 2x power. What if you took the derivative of that inner function e to the 2x power? All right, doesn't that kind of resemble this thing over here? What you use the substitution method when you have an inner function and an outer function, and in particular where the derivative of the inner function is a factor that's being multiplied by the outer function. All right, that sounds kind of complicated, but you know how this is used, so let's go ahead and clarify just by working it out. We're going to let u be the inner function here. U is going to equal e to the 2x power. And then we've got to figure out what the derivative of u with respect to x is. Alright, and if we use the chain rule, we're going to figure out that that's equal to 2e to the 2x power. Alright, I'm going to do one thing here that I haven't done in the past. It's just a different way of writing something. I'm going to multiply both sides of that du dx equation by dx so that I get du is equal to 2e to the 2x power dx. It's going to make the substitution look a little bit nicer here in a moment. So, the derivative of u was 2e to the 2x, which is not what this factor is, but we could rewrite 4e to the 2x as a multiple of that derivative, couldn't we? So let's go ahead and do that. Rewrite the function. 4e to the 2x power is the same as 2 times 2e to the 2x power, right? So let's make that 2 times 2e to the 2x power times the cosine of e to the 2x dx. And then we'll do our substitution. So we're going to have 2 times, and here's why I wrote this u thing the way that, in a slightly different way, the du dx in a slightly different way. We're saying that du is equal to 2e to the 2x dx. Well, let's highlight something here. Within our function, don't we have a 2e to the 2x dx? And so that part right there is going to become our du. And then we'll go ahead and replace e to the 2x with u. And so we'll have 2 times the integral of cosine of u du. And then it's just a matter of integrating the cosine of u. The cosine of u we know is going to be the sine of u. So we'll get 2 times the sine of u plus c. And we'll go ahead and put e to the 2x back in place of u. So that we get 2 sine of e to the 2x power plus c for our integral. Alright, now I'd like you to try the next one on your own just to make sure you've got the idea. But that's basically it for integrating with trig functions. Alright. Here's your last example. Pause the video, try it, see how you do. Alright, you see what I made my value of u equal to and where I found du, dx, and so forth. Let me rewrite the function a little more clearly so that maybe you can see why I chose that particular value for u. And what I want to emphasize in particular with that is this cosine cubed of x part. That could have been written as a cosine of x cubed, which here's where our composition is. The outer function being a cubic function, the inner function being a cosine function. And so it was the inner function that I let u be equal to, right? Alright, now you also see where, since du dx was negative sine x, I rewrote the sine of x as negative 1 times negative sine x. And that's just to make that substitution a little bit easier. Just like with the previous one, I have a negative sine x dx that I could use for my du. And then I can replace the cosine of x with u. So that the derivative is going to look like this. We're going to have negative 1 times the integral of u cubed du. And then this is going to be a simple power rule thing here. We're going to have negative 1 times the integral of, well, times 1/4 u to the 4th power plus c. Go ahead and rewrite this in terms of the cosine of x. We'll have 1/4 times the cosine to the 4th power of x plus c. Alright, integrals with trig functions. Good stuff. See you later.